energy consultant from Utrecht. And today I will tell you something about an exploration of future electric mobility and charging infrastructure that we recently did. So let me start off by telling you that I was on skiing holiday last week. We do that with a group of friends for 10 years now. And I remember vividly that 10 years ago I was in the car with them. You have a pretty long drive. And at the time I said to my friends, well, you know guys, I think that by 2020 we will pretty much have quite a lot of electric cars already, and electric cars will become quite common. And they thought of me as some kind of environmental activist, and they laughed at me. This year now, roughly 10 years later, we were driving through Germany on our way to skiing, and we stopped at a Autohof, which is one of those desolate places where you can get Burger King and top up your gas. And we drove into a Tesla fast charging station. And at this point I had to remind them, well guys, what do you think about the statement that you did 10 years ago? And indeed they told me, well, we have to say electric mobility has come a long way. And if we think about it, I went back to 2008, we had the Tesla Roadster, which would cost over $100,000 with a range of 320 kilometers. And then if we look now, we have a car that is only 40% of that price with more range that is coming onto the market in 2018. And then the question, of course, is what will happen towards the future? And this is going to be the topic of my talk. What can we expect in the long term? I'm very happy to be working at Ecofys at this moment, so that it is actually my job to think about these things, whereas, well, back in the days I would just discuss them with my friends. And we were contracted by the Ministry of Economic Affairs, Martin Hamelink, who's also present here today, to do a scenario analysis of what will be the uptake of electric vehicles, and in turn what will be the required charging infrastructure in the long term in the Netherlands. This is a study that we did with Ecofys and also with the Technical University of Eindhoven at the end of last year, and which fed into the vision of the Ministry on Electric Mobility. So we started off by saying, okay, we're going to formulate scenarios. And what should these scenarios entail? What will be the key drivers that will shape how electric vehicles are brought to the market? What kind of charging infrastructure we will need? And we said, okay, let's first look at the energy transition. And we said, okay, let's put a horizontal axis, which says, a vertical axis, which says at the bottom we have a slow energy transition, which means that battery prices do not go down very fast, which also means that the costs of fossil fuels stay relatively low. And on the other hand, we have a fast energy transition where the TCO of electric vehicles goes down rapidly, where we also see the prices of fossil fuels go up faster. And we said, okay, there's a second big trend that will shape how electric vehicles and mobility as a whole will be developing in the coming years. And that is the sharing economy and autonomous driving. We said on the horizontal axis we have a limited sharing economy, we have limited autonomous driving, and on the far right hand we say, okay, there's a lot of uptake of car sharing initiatives, and also autonomous driving kicks in at roughly 2025 was our estimation. If we go back to the original question, we said, okay, we're going to do a forecast of how electric vehicles will be taken up in the market and what kind of charging infrastructure is needed. And we said, okay, we do this in 3 steps. First step will be a TCO model. Second step will be a stock model, an uptake model. And the third step will be thinking, okay, what kind of charging infrastructure do we then need? So if we start on the left-hand side and we think about the TCO model, what we did is we started off with defining user groups. Who actually drives these electric vehicles? And we said, okay, there's essentially for cars, there's essentially 3 main user groups that we can distinguish. That is private drivers, so people that use their car only for doing groceries perhaps in the weekend, doing a trip to grandma. Commute drivers that use their car daily to go to work. And we have business drivers, so here you can think about representatives that really have a very high annual mileage. For these user groups, we did a TCO analysis that basically shows how the costs of driving an electric vehicle compare to the costs of driving a fossil fuel vehicle. Then these developments that I mentioned earlier, so battery cost developments, those were varied throughout the different scenarios. And as a result of this, we had a projection of how the TCO of electric vehicles would develop into the coming years. This fed into the second part of the model, which is the uptake model. The uptake model is essentially a stock model, so this is a model that projects the car sales and also the removal of cars from the total car fleet in the Netherlands, and in that way projects how many cars we will have, electric cars we will have in future years. Key elements there were that we use the TCO, so the total cost of ownership, and also the consumer willingness as a factor, more of a soft factor to show, okay, perhaps if the TCO is profitable, then still there would be reasons for people to not right away buy the electric car, but they would still have to be convinced. So this was more of a soft factor. As a result, from the second part, we would get the forecast of how many electric vehicles we would have in the Netherlands from now until 2035. Then the last part of the model was a charging infrastructure model. The charging infrastructure model used the results of the former two modules, and based on the OVIN data, which is the data that is collected on how people actually drive their cars and what kind of trips they make, we use this to specify, okay, what opportunities do these different user groups then have to charge? So a commute driver, which kind of trips does he make and which part of those trips goes to his work, but also which part of these trips go to the shopping mall, and what opportunities does that in turn offer him to charge its electric vehicle. And this was the basis for the charging infrastructure part, where we said, okay, there's a preference of users to charge their vehicle at home or at work. If that is not possible, they will try to use public charging. And if they drive long distances, they will use fast charging points to top up their vehicles. As a result of this third module is then the forecast of the number and type of chargers needed for electric vehicles over time. So to give you a bit of an idea of what the results look like, and I encourage you to also have a look at the full report, which is on the Ecofys website, but here I show the results for scenario 1 and scenario 4. Scenario 1, if you remember, was a slow energy transition combined with very limited car sharing and autonomous driving. And we see here that by 2035 we end up with roughly 3 million electric vehicles. Know that we have a little over 8 million cars in the Netherlands, so this is getting towards half of all cars being electrified. And a strong growth in the number of chargers that we would need, particularly in the work charger and public charger segment. If we then look at scenario 4, we see that we would end up at roughly 4 million electric vehicles. What's interesting to know here is that the total stock of cars has actually been declined because of high use of car sharing initiatives. People need less cars. So in total 1.5 million cars were taken off the road because of a high amount of car sharing use. And we also see that here, once again, a big number of charging points is needed. Interestingly, we see that actually towards 2035, a decline in the amount of charging points is needed because what we did in the research was we said, okay, if autonomous driving kicks in, you will get a very high utilization of charging points as autonomous vehicles can uncouple themselves when they are fully charged and make room for a new vehicle to be used again. Some of the key conclusions that we drew from our research. As said, we defined different user groups, 3 user groups for cars, and we also looked at vans, light commercial vehicles. And we said, okay, let's look at the TCO and when does it become profitable over fossil fuel vehicles. And for business drivers, we say, well, that's very close. We expect with the models entering the market next year that already a business case can be made for electric vehicles for people who have a high annual mileage. For commute drivers, we expect that to happen before 2020. So either depending on how fast the prices drop between 2018 and 2020. For private drivers, so people that do not have a high annual mileage, we expect this to happen somewhat later, but at least in the coming decade. If we then think about what is needed in terms of chargers, and here I took a bit of a shorter time frame, so let's focus on 2020. And here we said what will happen is that the first group of drivers for which electric vehicles will become profitable are probably the business drivers, people having a high annual mileage. And if you then in turn think about, okay, where do these people have the opportunity to charge, that is most likely at work, because they are there a lot. So we need a lot more work chargers. Also, currently there is people that own an electric vehicle have typically a larger house, and they also have the opportunity to install a home charger. What will happen towards the future is that also people that do not have their own driveway, do not have their own garage, will buy an electric vehicle, and they will be dependent on public chargers. So we expect that we will need a very steep increase of public chargers also in the very near future, towards 2020. And then for home chargers, well, still an increase will be there, but as said, many people will also start buying electric vehicles that do not have the opportunity to install a home charger. Looking at the trends of car sharing and autonomous driving, we have found studies that show that the technical potential for car sharing is to take off 50% of all cars from the road. If we start using car sharing to a very large extent, we would need only half the cars. Fully autonomous vehicles, we think that they could enter the market at around 2025. And we expect also that fully autonomous vehicles will be a major boost for car sharing initiatives. As if you park your car somewhere and you could give it the assignment, well, go earn money for me, pick up people and drive them around. That could very much be a boost for car sharing initiatives. And lastly, if we look at the combined impact of car sharing and autonomous driving, we expect that if those two developments really take place, we would need 25% less charging infrastructure compared to the case where you have very limited car sharing and autonomous driving. Some recommendations that follow from the work that we did. We expect that electric vehicles will take off mainly in the business driver and commute segments. So we will need much more public charging infrastructure and work charging infrastructure. Car sharing and autonomous driving are two major game changers that could really enhance how we fulfill our mobility and also could be a major boost for electric mobility. So look at how can we stimulate it through innovation, but also how can we remove the legislative barriers that are currently still there, so that once these vehicles do become available, we can actually use them on our roads. Smart charging services, it's been touched upon already by several of the speakers. Smart charging, as Cornelis said, fits like a glove to the energy transition. And we think that it's important that we develop a system in which you are actually rewarded for your smart charging activities. And lastly, and this really relates to the user aspect, we need to better understand how users want to use their electric vehicle? What are their preferences for charging? What do they need to be convinced to buy an electric vehicle? And also very importantly there, what is the relation between fast charging and public charging or home charging? Could fast charging at very high speeds in the future remove some of the pressure on the public charging points and home charging points? I will wrap up here. I think in 10 years from now, when I'm going to my next skiing holiday, I really hope that I can tell my friends, well, I told you so in 2016 when I said autonomous driving will be the next trend. And I really hope that you can all contribute to that. And if you're interested for the full report that we did for the Ministry of Economic Affairs, you can find it on our website. And thank you very much for the opportunity to present here.
Thank you, Mark. Well, of course, we want to know if you went on your